Didn't do question 5, so now we're going to go back to question 5. So I totally skipped over question. I skipped over question 5 and did question 6. That was question 6. So all of this is question 6. All right, let's go to question 5 then. My apologies, not doing it in the right order. All right, question 5 now. I totally missed that. Question 5. Question 5 says, 10 students across the Caribbean community apply for mathematics scholarships. 3 of the applicants are females and 7 are males. The scholarships are awarded to 4 successful students. Determine the number of possible ways in which the 4 applicants may be selected if no restrictions are applied. So if no restrictions are applied, so part 1, no restrictions are applied, that means we can, from the 10 persons, we can choose any 4 persons. So it's 10, choose 4. You just put that in your calculator, 10 choose 4, that's 210. So there are 210 ways. There are 210 ways you could choose with no restriction. 210 ways to choose with no restrictions. Nice. Restrictions. All right, that's the first part. That's just 1 mark. That's the warm-up. It says at least one of the successful applicants must be females. So to do part 2, right, in order, number of ways where you have at least one, you must have at least females. So it's going to be the total ways. It's going to be the total ways minus the number of ways with no females, minus no females. Right, so we need to find the total number of ways minus no females. The total number of ways we just found was 210 minus no females. To have no females mean we would be choosing 4 applicants from how many boys? That is 7 boys. So we're choosing 4 from 7, and we're not choosing no girl times we're not choosing no girl from 3. All right, that would give us the number of ways of choosing at least one girl. So that will be equal to, put this in our calculator. So it's 210 minus 7 choose 4 times 3 choose 0, 35. So 210 minus 35. And so that's equal to 210 minus 35, 175. So there's 175 ways of choosing at least one female. That's part 2. Now part B. Part B tells us that we have, part B says, numbers formed using the digits 1, 2, 3, 4, and 5 without repeating any digit. Determine the greatest possible amount of numbers that may be formed. And so let's go to this box right here. I like to draw a box and then cut it up into based on the amount of things that they want. So 1, 2, 3, 4, 5. 5 boxes for each digit. Let's say find the number of, determine the number of digits that can be formed if we're not repeating any digits. So if we're not repeating any digits, right, we can have 5 digits go here. This is the amount of 5-digit numbers. So first I'm going to start with the amount of 5-digit numbers. 5-digit numbers. The amount of 5-digit numbers that can be formed are, in here you can have Any number can be at the end, so that's 5. Any number, then 4 other number can go here, then 3, then 2, then only one number can go here. So the number of 5-digit numbers that can be formed is 1 times 2 times 3 times 4 times 5. That's the amount of 5-digit numbers that can be formed. 1 times 2 times 3 times 4, 3 times 4 times 5. That's 120 5-digit numbers. All right, let's see how many 4-digit numbers can be formed. Again, I like to draw my box. I'm going to draw my box, but this time I'm going to cut it up into 4 pieces. So I know I can have 5 number here, 4 number here, 3, and I have 2. So there is going to be 1 times 2 times 3 times 4, which is not 1, 2 times 3, 2 times 3 times 4 times 5. That's also 120. So there are 120 4-digit numbers that can be formed. All right. There's 120 4-digit numbers that can be formed. So the amount of 3 digits now. The amount of 3 digits. Remember using numbers 1 to 5. All right. So the amount of 3-digit numbers that can be formed now, right, would be 5 number can go at the end, 4, 3. So now I multiply them, that's 1260. So there are 63 digit numbers that can be formed. So there's 63 digit numbers that can be formed. And then how many 2 digits? I can already see the trend. 5 times 4 is 20. So there can be 22 digits. 22 digits. And if you're not, there are 22 digit numbers that can be formed and 5 single digits. All right. There can be 22 digit numbers and 5 single digit numbers. If you're not following, I'll give you some examples to make you understand why this is so. Remember, we're choosing from 1, 2, 3, 4, and 5, right? If you have 1, 2, 3, 4, and 5, how many single digit numbers that you can get? Only 5 single digits, right? See there, 5 single. And if you have 1, 2, 3, 4, 5, how many 2 digits you can get? You can get 1, 2, that's a number, 1, 3, 1, 4, 1, 5. You can get 2, 1, 2, 3, 2, 4, 2, 5. You can get 3, 1, 3, 2, 3, 4, 3, 5, or you can get 4, 1, 4, 2, 4, 3, 4, 5, or you can get 5, 1, 5, 2, 5, 3, 5, 4. How many 2-digit numbers this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Count up 20. So this will give you your 5 single digits, and this would give you your 20 double digit. All right. So that's how I get the 22 digit. You do the same to get 63 digit, 124 digit, 125 digit. And so the total possible amount of numbers now. So the total possible numbers is going to be equal to the total number of 5 digit plus the total number of 4 digit plus the total number of 3 digit, and so on. So it's 120 plus 120 plus 60 plus 20 plus 5, which is 325. So that's part I. Nice and easy. That's part I. Now the last part now, it says find the probability that a number form is greater than 100. So find the probability that a number formed is going to be greater than 100. So the probability that a number is greater than 100 is the total amount of numbers that can be bigger than 100. Those are 3-digit numbers. How many 3-digit numbers are there? There are 60 plus 120 plus 120 plus 120. So there are 300 numbers bigger than 120, and then it's divided by the total amount of numbers, total number of numbers that can be formed, which is 325. So the probability of a number being bigger than 100 is, add up this, divide by 325, that's 300 over 325, 300 over 325, and 300 over 325 is equal to 0.300 divided by 325, 0.923, 0.923, 0.923, right? 0.923. Nice and easy, soft. That's part 2. All right, that's part 2. Nice. That's part 2.